So today we're going to talk briefly about the behavior of what we call zeros, roots, or x-intercepts. I've written at the top here that these three words can be interchanged for one another. They all refer to the same thing. So zero, root, or x-intercept. Basically, anytime my graph crosses the x-axis, we're referring to that as a zero, a root, or an x-intercept. Okay? We can also talk about briefly multiplicity. That's just how many times the zero is repeated. That tells us what event is occurring at the zero. So here we can see a zero with a multiplicity of 1. All right, I've got both a picture and a description. So we can see that the graph goes through that point on the graph. So here, if we have a 0, my graph goes through it. If I have a 0 with multiplicity of 2, then my graph just kind of bounces off or reflects off that 0. So here you can see it approaches the 0, it touches at that point, and then reflects or bounces off down into the same direction. Finally, a 0 can have a multiplicity of 3. This is where the function either turns, swivels, flattens, whatever term you would like to use best to help you kind of notice that as it approaches, it starts to kind of look as if it's going to bounce off, but then it actually turns almost like I flipped it. Instead of it bouncing off this way, it kind of bounces off in an upwards direction. So those are the three types of multiplicities that a 0 can have. Once we understand that, we can now combine what we have just learned with what we talked about in class in regards to the end behavior of graphs. So the first thing you want to do is plot the zeros. So here you can see I have zeros at -1, 2, and 5. Nothing else is listed as far as multiplicity, so I assume that they all have multiplicity of 1. If it's not stated, you understand it has to be a multiplicity of 1. So I'm going to plot my zeros. So I have zeros or x-intercepts or roots at -1, at 2, and at 5. From there, you'll notice we determine the end behavior of the graph. Okay, so this is a positive odd function. So I know that my endpoints are going to look something like this. They're going to go opposite because it's odd, and they'll go in this direction based on the fact that it is a positive function. So what I can then do is kind of connect the end behavior with the outermost zeros. Okay, so I know at this point, it's going to kind of go down. All right, this is my 0 furthest to the left, so that's going to affect this endpoint. I know once it gets past this 0, it's going to increase, so I'm just going to draw an up kind of arrow like that. Now I'm going to think about the multiplicity. So I know that when I have a 0 with multiplicity of 1, it goes through the graph. So here we go. Okay, and then I think about this 0 as well. It has a multiplicity of 1, which means it's going to go through. And then this 0 also means it has a multiplicity of 1, so that means it's going to go through. And then you just kind of think about how it would connect. You don't need to worry about how high or how low it gets, but this would be the general shape. It would be increasing as I approach the x-axis. It has a multiplicity of 1, so it would go through. Okay, and then it would need to come down at some point to go through this 0, and it has a multiplicity of 1, so it goes through. And then again, it would go through this 0 and up on as it needs to increase as x approaches positive infinity. Second example. Okay, here I have zeros at -3, 0, and 4. So the first thing I want to do is plot again my zeros. -3, 0, and 4. I know it is a negative even function, so that tells me I'm going to have kind of those two downward arrows, or that's what it's going to look like. So if I think my 0 furthest to the left, it's got to go down. And again, on the right must also go down. So you'll notice here at -3, it says multiplicity 2. So I go back up to what I learned briefly, and I know that when it has a multiplicity of 2, as it approaches a 0, it just kind of bounces off. Okay, when I have multiplicity of 2, my line or my function just bounces off or reflects that 0. When I have a 0 of 0, again, nothing is stated here, so this is assumed to be a multiplicity of 1. I know it's going to go through that 0. And then at 4, it has a multiplicity of 3, so I know it's either going to turn or swivel or flatten. So again, here it kind of flattens, and then it flattens back up. Now from here, I just kind of connect it there with a little curve, and I know that it is going to look something like that function. I'm not worried exactly about the curves. All right, what I'm looking for is you have the correct endpoints and the correct zero behavior at each zero according to the multiplicity. All right, you can jot this information down. Once you have this copied down, or right now, I would pause, all right, the screen, as I'll then go ahead and give you the answer. All right. As a last spoiler warning, if you don't want to see the answer, pause it now. Otherwise, you're going to plot our zeros at -2, at 0, and at 4. Positive even, that means it's going to rise on both sides. Okay. At -2, it doesn't say anything, so it's got a multiplicity of 1, so I know it goes through. At 0, it's got a multiplicity of 1, so it's going to go through. And then already I should see that in order for it to go back up, it's probably going to be just bouncing off because it's not going to cross the x-axis anywhere in between. And I know that to be true because this 0 has a multiplicity of 2, which says